Okay, Cartesian equation of a plane with three coplanar points. So we're on some plane. We have point A, point B, point C. We need to figure out two directional vectors for this plane. Well, if we have 3 points, we can definitely find out 2 different points. In fact, we'll use A as our colliding or intersecting point. And we can talk about now having vectors AB and vector AC. Once we have those 2 vectors, we have 2 directional vectors for the plane. When we have directional vectors for the plane, we can find the Cartesian equation of the plane very quickly by finding a line perpendicular to it. So, first, I need point A and B. So, vector A, point 2, point 1. Let's do this very quickly. 3 minus 1, sorry, 3 subtract negative 1 is 4. 2 subtract 2 is 0. 4 subtract 5 is negative 1. Vector AC. Negative 2 subtract negative 1 is negative 1. Negative 3 subtract 2 is negative 5. 6 subtract 5 is 1. There are directional vectors for A and vector AB and vector AC. When I have these 2 directional vectors, I can find the cross product. Cross product of vector A cross vector AC to determine a directional vector perpendicular to this. If you guys remember that equation, it is A2 B3 subtract A3. I gotta zoom in for this. B2 A3 B1 subtract A1 B3. A1 B2 subtract A2 B3. I know you guys have a cross way of doing it. Amazing. Go for it if you guys have that matrix style way of doing it. A2, we'll call this vector A, vector B for simplicity's sake. That gives us 0 times 3, which is going to be nothing. Or sorry, 0 times 1, which will give you nothing. And negative 1 times negative 5. It's positive, so we're going to end up actually with a negative 5 because we're subtracting positive 5. So we'll do it like that so you know what I mean. A3, again, negative 1 times B1. Negative 1 times negative 1 is going to be 1. Subtract A1 times B3 is 4 times 1 is 4. And A1, which is 4 times B2, negative 5, gives us negative 20. Subtract A2, which is 0 times B1. Doesn't matter, it's going to be 0. Okay. So we're looking at negative 5, negative 3, negative 20. This is a perpendicular directional vector from vectors A, B, and AC, which means this can represent our normal. This will be perpendicular to that point. If we have the normal Cartesian form of the plane, AX, BY, CZ, D equals 0, we have our normal, which gives us negative 5x. This is our A, B, and C values. Negative 3y minus 20z plus D. We just need some point on the plane to solve this in order to go through it. And once we have a point, we're just going to sub it like in the last one, that point for x, y, and z. Okay? And we know that our points on the plane, we can essentially find out any of the points on the plane. I could have used B, which is 3, 2, 4. I'm going to do that. 3, 2, 4 to solve for D, which gives me negative 5 by 3, negative 3 by 2, negative 20 by 4, plus D equals 0, 15, 6, 80, which gives us 95, 101. D is 101. So, Cartesian form, plus 101 equals 0. Boom. I apologize for that being so fast.